All right, last two questions of the day. So let's look at secant 2x, tangent 2x, and then the square root of tangent x, secant squared x. This class is going to become a puzzle. It's going to be one that you may not like. What? Go ahead. Enjoy. Come say hi. If you look at these two questions, now we have secant tangent. Now, I will always tell you, positive now, that secant and tangent are always going to be together. So sine and cosine are usually together, and then you have a secant and tangent. So again, I'm going to do something that's wrong. If I make u, so please don't write this down, this is wrong. If I make u secant of 2x, my derivative, do we remember? So first of all, let's remember the derivative of secant of x. The derivative of secant of x is secant tangent. Do we remember that? If not, it's okay. Yes. But the derivative of secant 2x is secant 2x tangent 2x times 2. Do we remember that? Because it's secant of 2x, that's something else, and you realize that's good. So secant of 2x, tangent 2x, and then you still have to multiply by the derivative. So if I take out secant of 2x for my u, I need all of this. Now I really don't care about the 2, but I need all of this, what's left over. What I only have is my tangent 2x. So I'm missing a secant of 2x. So we can't use u here. Okay? So we don't have what we need. So let's go to the second part. Again, please don't not write this down because this is also wrong. Let's make u the tangent of 2x. Well, what's the derivative of tangent of x? Well, the derivative of tangent of x is secant squared. So my derivative of this, if this is u, my derivative is secant squared 2x, again, times 2 dx. Well, if I get rid of this, how many secants do I need for this to work? I need 2 of them. How many do I have? 1. So again, that doesn't work. Anyone have an idea what my u is here? Because this is a u sub question. Well, what else is there? What else can we do? Yeah. Let's make it the theta. Let's go back to what we started the class with. This is correct, by the way. So u is equal to 2x. du is equal to 2 dx. And again, I do not have a 2 anywhere in my integral, so I'm going to pull out that 1/2. So let's look at this for a second. 1/2, and then what am I left with? I'm left with secant u tangent u du. Now I just told you earlier, secant and tangent are always going to be with each other. You told me earlier today that secant squared u du is equal to what again? What is the integration of secant squared? Tangent. You know this because the derivative of tangent is secant squared. So you have to ask yourself which trig function's derivative, because there is one, is secant tangent. It's secant. So this actually integrates to simply secant. So again, most of these puzzles that I call them puzzles, I'm going to tell you what you have to do. Like I'm going to tell you in the class what you have to do, because it's always going to be these type of questions, right? You're not going to get any wackadoo thing from left field. So we have this right here. So this is why, again, this class, I know sometimes it gets frustrating that you can't let things go, you can't forget things. It's like a snowball rolling down a hill, like becoming an avalanche. This is going to be this, and then how do I finish the question out? What's my final answer? I have to do 1/2 secant, and then I have to replace my u with 2x plus c. And if you were to take the derivative of that using the chain rule, which again, we're going to refresh our memory on that later on in life, then you actually are going to get that back. You're going to get that back. All right, last one. Are we okay with that? Okay, so why this class is sometimes frustrating for students is now let's look at this question. Yeah, wait, there we go. Completely different from that one, even though we still have the same 2 trig functions. The other thing that kind of sucks about this is they're both raised to a power. We have one on their radical, so that's 1 to the 1/2, and we have one that is square. But again, let's go back to the very first thing I taught you with u sub. Is one's function's derivative beside it? Yes. One's derivative is setting right there. So what's my u here? It's tangent. It's tangent of x. So that means my derivative is secant squared x dx. It doesn't matter that I've got parentheses around that. Sometimes it doesn't matter at all. So again, last thing for today, I highlight this. My u is right here. My du is all right there. You know you've done the question correctly if everything that is here has now been taken care of. So it's the square root of u du. All we have to do is change our bounds. And then when we change our bounds, we're going to integrate this really fast and we're going to call it a day. The tangent of 0. It's 0. I have told you guys my shortcuts for tangents, right? If not, I'm going to tell you again in a second. Because this, I don't want you to get overcomplicated with this. Tangent of pi 4 is the easiest one. Say what I did. One, easiest one. Okay. What? Sorry, that was lame. I'm sorry. And now we back. So now this is our problem. That's the problem that we have to do. So let's knock this out, and I'm gonna really quickly tell you the tangent stuff, and then we're gonna, like I said, we're gonna call it a day. So integrate u to the 1/2, we get u to the 3/2. Is everyone okay again with the 2/3 on the outside? If we integrate u to the 1/2, we add 1 to the power, we get 3/2. So we're gonna go ahead, if we're divided by 3/2, we multiply by 2/3. 0 to 1. We notice that a lot of these definite integrals end up becoming 0 and 1, right? That's kind of nice for us because I know this is really silly. We don't really have to pull out the 2/3, but I just want to show it for one last step here. Pull out the 2/3. I plug in 1. 1 to the 3/2 is 1. I plug in 0. I get 0. So the answer to this problem is going to be 2/3. One of the things we're going to do on Thursday, we're going to talk about total change. But what I'd like for us to do on Thursday before we start working is see if we can remember how to plug this sucker into our calculator and make sure that you get out to 2/3. Last thing I want to do, actually I'm going to close out this lesson.